Now we're going to look at stretching and compressing. Same thing, we want to identify that critical point. If you take 0, 0 and multiply it by 3, you still get 0, 0. For stretches and compressions, the critical point won't change. Again, we'll look at domain and range from the graph. Notice our t-chart for this one, the x values are not -2 to 2 like they were when we looked at the translation. For the square root function, you want to put perfect square values into the function so that you get integers out of the function, which makes it easier to graph. Our parent function, as we just said, was the square root. Square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. And the square root of 16 is 4. Next, we think about what are we doing to the function. Notice that the 3 is on the outside, so it is vertical, and it's a stretch because it's outside the asylum, so it's normal. We're not doing anything to x, so our x values will remain the same. Those y values will get multiplied by 3. Copying down all of those x values from my first column and multiplying all of the parent function y values, or outputs, that we generated in that second column by 3. Next, we'll plot our points from the last two columns. Because this one I need to go up to 9, 9, 16, 12 won't fit on my graph, I'm going to call each of these bars 2 instead of 1 like I did in the last few. Plotting those points, we're still starting at 0, 0. We have 1, 3, 4, 6, and 9, 9 is the last one that'll fit on the graph. The square root function, remember, starts at 0, 0. You can't put a negative into the square root function and get a real number out of it. To compare this to the parent function, so that you can see how it was vertically stretched by 3, I'll plot some of those parent function values. This is what the parent function looks like, that red graph. You can see that the purple graph was taken and kind of pulled vertically by a factor of 3. That's how we get our stretches. Going back to our domain and range, notice that our domain and range is the same as the parent function. We're starting at that same point. All of the positive x values can be put into the function. Our domain is greater than or equal to 0. And same for the range. We get positive values or non-negative values out of the function. In our last example, we have a horizontal compression. Notice that that 2 that is inside the parentheses being multiplied by the x looks like it would stretch the graph by a factor of 2. But because it's grouped with the x, it's in the asylum, it's not normal, it's actually shrinking the graph by a factor of 2. For our stretches and compressions, multiplying the critical point of 0, 0 by 2, or 1/2 in this case, still keeps it as 0, 0. Our parent function, notice we have the power of 3 on the outside, so we have x cubed for our parent function. Cubing all of those x values, we get -8, -1, 0, +1, and +8. This time our stretch or compression is affecting the x. Again, that 2 looks like we should multiply the x by 2, but we're going to flip it and multiply by 1/2 instead. Our y values are being left unchanged, cutting all of those x values that we started with in half. And all of the y values are left alone. We'll plot the purple columns for our new compressed function. Starting off with -1, -8. Again, I'll scale each of those by 2 so I can fit my points on the graph. Then we had -1/2, -1, 0, 0, 1/2, 1, and 1, 8. The cubic function does curve. With this horizontal compression, it gets really skinny towards 0, 0, so it's a very flattened curve, but you should still have some sort of curve going on with your graph. To compare this to the parent function, we had -2, -8, -1, -1, 1, 1, and 2, 8. So you can see that this was squashed towards the y-axis, or horizontally compressed, by a factor of 1/2. Domain and range for our parent function as well as our compression, all real numbers for both. There's no U-try on this video, as these graphs tend to take a bit of time. So if we need to, we can pull up a question from the assignment and take a look at it together.